In order to solve for the kinetic friction, we will use the formula that the force applied is equal to the weight times the mu k. And the weight is the same thing as force normal. Next, we're going to plug in the numbers. Then we simply isolate the variable and we receive our mu k. Once we divide, we receive 0.6923. This is our coefficient of friction. Next, we are asked to identify the tension, where the tension is, and who applies it, and how they apply it. In order to solve for this problem, I drew a diagram. This is the person pulling and exerting a force of 36 newtons to this rope. Apologize. Let me get rid of this. He's exerting it to this rope, but this whole sled is also exerting a force upon the rope, and therefore he's exerting the force right here, while the sled is just exerting the force of the same exact amount right here. The tension is 36 newtons because this is the amount that the amount of force that this kid is applying to the rope. So this is our tension. Next, we were asked to solve for the acceleration of the sled in the case that it is being pulled on an incline of 30 degrees for 10 meters, and we are assuming that we have the same weight, same applied force, and same coefficient of kinetic friction applied. In order to solve for the acceleration, we're going to use the equation, which is F net is equal to mg, which is essentially also our force normal, times the sine of theta, which is 30 in this case, minus mu k, which is what we solved up here, or right here on the left, times mg, which is also force normal again, times the cosine of theta, which is 30. And since F net is equal to mass times acceleration, then what we receive here is also going to be equal to mass times acceleration. And you'll see later how this plays a role in solving for the acceleration. Now we have to plug in our number. Then we're going to simplify. I'm going to skip through my solutions because I'm assuming that you know how to do algebra. If you don't, have another tutorial on that. I'm going to skip through that and I'll show you what the product is. Once you have done all the work, you end up with an F net. But now you remember that it equals mass times acceleration. So what we're going to do is we're going to convert newtons, so our weight in newtons, to kilograms. And the conversion is newtons divided by 9.8 equals mass in kilograms. Next we will plug in all of our numbers. And so 52 divided by 9.8 is 5.306 kilograms. And this is our conversion. Next we would just plug in our mass into this part. And that gives us only one variable left, which is acceleration. So then we just simplify, divide, and we receive our acceleration, which is 0.97558. In my calculations, I forgot a few decimals here and negatives here and over there. But when I was doing my calculations, I realized and I added them, and this is the acceleration that I got. Next, we are told to solve its final velocity or speed when it hits the bottom of the ramp if it were to be just completely let go from the top of the inclined plane. In order to solve for its speed, we're going to be using the equations work equals F net times distance and work equals 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared. We're going to start with this equation since we have most of the knowns. Now let's plug in. 5.17657 is our F net, which we solved way back here, which is right here. And 10, we got the distance from right here, because it's a following problem. Then we just simply multiply, and we get negative 51.7657. That's our work. Now, when I was calculating, way back here, I made a, I basically told that my downs, when the object would be moving down, it would be actually going up, and therefore the negatives are screwed up a little bit. But as long as they're basically opposite, but as long as in the end it will all work out because they are opposite. Next, we plug into this equation the number that we got here. This is what the equation should look like after we plug in. Next, we're just going to simplify, and if you notice, this part was actually taken out, because if you think about it, our initial velocity was just 0 because it's starting from the top of an inclined plane from rest. So this part all canceled out, so you're left with 1/2 mvf squared equals work. And then you simplify, do the algebra, and you should get your final velocity. After we simplify, we get the final velocity of 4.41871 meters per second. Last but not least, we're supposed to calculate how fast a 70 kilogram person and the sled would go if they were to hit each other after the collision. After they were to go down the ramp. To solve this problem, we're going to use the law of conservation of energy. The equation for that is basically that the mass of the sled times the velocity of the sled is equal to the mass of the sled times the velocity final of everything plus the mass of the person times the final velocity of everything. So now we're just going to plug in, and here we're gonna just simply add these and add these. So the final velocity of all the objects is 0.31148 meters per second. Now, you might wonder why it's so small. Well, if you think about it, it's not going at a very high velocity in the first place because it's only about 4.5 meters per second, and its weight is not that high compared to the 70 kilogram person. So they would not be going that quickly